Welcome back to our channel. The question today is about calculus, calculating area under a curve. We're told find the area bounded by the curve y is equal to x cubed plus 5, the x-axis, and the lines x is 1 and x is 3. So the first thing, we are going to roughly sketch. So let's have this. So let's have this as y-axis and this here as x-axis. So just from the equation here, we can take note that the y-intercept is 5. So if x is 0, y is 5. So that's where we are going to have the curve beginning. So at this point, and then let's have something like that. So this is curve y is equal to x cubed plus 5. So you don't need to be very accurate with this. We're just sketching so that you have a full picture of what we are doing. So if that is the curve, we also have the x-axis and the following lines. Line x is equal to 1. Line x is equal to 1 is a vertical line meeting the x-axis at point x is equal to 1. Then we also have line x is equal to 3. That is another vertical line meeting the x-axis at point x is equal to 3. So we have this region here bounded by the 4. We have the curve. Line x is 3, line x is 1, and the x-axis. So we are going to find the area shaded in that diagram. So we are going to determine this by integration. When we're integrating, the area is, we integrate within the limits. So we have the limits from x is 1 up to x is 3. So we begin with x is equal to 1 up to x is equal to 3. We are going to integrate the curve y is equal to x cubed plus 5. So we have x cubed plus 5 with respect to x. So when we integrate, we're going to have this. So integrating x cubed gives us x power 4. So we add 1 to the power and then we divide by that power 4. Plus, now when we integrate this, we get 5x and then we introduce a constant c. So 5 integrated, remember 5 is just 5x power 0 and number raised to 0 is 1. So this is like 5 times 1. So what we've done here is 5x. So the power is increased by 1. So 0 plus 1 is 1. And then we divide by the same power, which is 1. So that's how we got, sorry, I hope that is understood. So that's how we got 5x. And then, of course, we add a constant c. Remember, we were doing this within the limits. X is equal to 1 and x is equal to 3. So the next thing, in order to determine the area, we are going to substitute these and get the difference. So we begin by the upper limit. So let's substitute in the first bracket. X is 3, so that we have 3 raised to 4 over 4 plus 5 times x, and x is 3. So at this point, we can just ignore c because at the end of the day, it will still disappear. Minus, for the second bracket, we substitute 1. So we are going to have 1 power 4 over 4 plus 5 times 1 is 5. So here we'll have, this is 81 over 4 plus 15. And then we'll subtract the right hand side. We have this a quarter plus 5, that is 5 and a quarter. This is like having the left hand side. From my calculator, I'm getting 35.25. And this one to the right is 5.25, just in decimals. And then when we get the difference, we finally get the area as 30 square units. And finally, we have the area bounded by the curve and the lines just as had been required in the question. With that, we mark the end of this problem. Thank you for watching. See you in the next one.